Now, Aaron, be honest. Do you miss Toronto already now that you've been away for 2 days?
I just miss the food. I'm not gonna lie. I don't
Yeah.
miss the travel. I don't miss the half hour to an hour drive to go do anything. Um, but okay, part of me wants to see a stoplight again. I'm not gonna lie. Like it's kind of neat, you know?
Don't you want to
Um,
see, Tim Hortons on two corners or all four?
yeah, yeah.
Yes.
So I don't know if you're aware, Steve, but I live on an island.
Yeah, Grand Man, and I
Yeah,
think
yeah,
I've looked it up before. You're
yeah. So we literally have no traffic lights on the island.
okay.
Like
Do you,
Do
do
you
you have
even stop
roundabouts?
signs?
Yeah,
we
do
have
you have roundabouts?
stop signs. We have stop signs. We're not quite that far back in the woods, but yeah, like a typical commute for me involves one stop sign.
Okay.
Um, you know, uh,
So do your cars have brakes, or do they? Is that like a feature that you have to pay for?
It's an
oh, you
option.
pay extra for that.
You
You
do.
pay extra
Okay.
for that. Yeah.
You just stick
Um,
your feet out like Fred Flintstone.
Yeah, there you go.
Pretty
Yeah.
much. Actually, it's a really high maintenance item on the island
Yeah.
because of the salt water and the
Mm.
proximity that people live to the ocean and short commutes that involve little braking. So I'm not sure which fails first, exhaust systems or brakes, but they're right there. Uh,
But it's from
because more
corrosion
often
either
than
way,
not,
right?
yeah. Well, the exhaust system doesn't get warm enough in most cases to actually dry out. Um, you know, whatever's happening, water being dumped from your internal combustion engine into the exhaust system, and it never gets hot enough.
Yeah.
Add a little salt, and well, it's the end of things.
Yeah. It sounds like a good way to accelerate the corrosion.
Definitely.
Yeah, but my mileage is incredible because I don't go anywhere. Uh, like quite literally, I fill up maybe once every 2 weeks, sometimes every 3 weeks. It's that
Wow.
is the bonus of living on the island. So, all
Wow.
right, what does everybody think? Should we kick this off?
Go time.
All right, excellent. All right, welcome to BS&BEER Canada. I'm Aaron Jones, and tonight I am drinking a Great Lakes Special. It's an Atlas Tools and Machinery Oktoberfest beer that I picked up in Toronto while I was visiting Connor. Before I pass this off to Connor, if you're in the chat, introduce yourself, tell us where you're from. It just gives other people in the chat an opportunity to know where their neighbors are. Cheers. Here's to you, Connor.
Thanks, Aaron. Hi, everybody. I'm Connor Malloy. I'm a builder, educator, and designer in Toronto. I teach building science and skilled trades at George Brown College, and it's great to be here and chat about all things that we love. Get nerdy for a minute, but also learn how to apply it to every building across Canada. Tonight, I am drinking Canuck, which is also from Great Lakes Brewery. But my camera will blank it out. Anyways, it's lovely, and it's just on the street from Atlas, where I saw Aaron. And yeah, over to you, Lori.
Hey folks, I'm Lori Rand. I'm based in Halifax and I'm like all the way on the east side of Canada on the map. And I am, hey, Valentine from PEI is here in the chat. We just had a chat about 2 hours ago, so hi again.
Yeah.
I am a Passive House designer. I am a Passive House educator, and I'm excited about today's show because I'm teaching a Passive House builder training in about a month, and I'm looking for some hot tips to give new builders who might not know how their way around a blower door test. And I'm drinking cocoa. I am so bad at coming up with a local option, although it is local. It is a company called Just Us Chocolate, and they are based here in the Maritimes. So, and I'll pass it on to Sean.
Well, good afternoon, good evening to you all. Maybe some good mornings in around the world. But I'm Sean Sainamore with Clay Construction here in Vancouver. So yeah, I'm over on that side, over about there. So we've got the full country represented here. Yes, and we've got Justin from Saskatchewan. So we got a few Canadians across the provinces, which is great. I've gone back to Stanley Park, Amber Ale. But of course, we're always talking about really good principles. And so my beer needs a sweater. So my good friends at Premier Automation are going to put my beer in a nice bright sweater. So my beer will be cozy for tonight's episode. I'm involved in a lot of fun things, Passos Accelerator, Passos Canada, and love to be able to talk about BS, but that's of course is building science with beers with my friends. So let's get the show started because there's nothing like a blower door conversation. And let's turn it over to our guest for the evening, Steve. Tell us about yourself. Tell us about what you got going on when it comes to other fancy red items.
I'm Steve Rogers, and I'm from the Energy Conservatory. We're a manufacturer of blower doors, and I'm almost in Canada, right in the north. If you're really familiar with the 49th parallel, there's a little notch in the bottom of, I can't remember if it's Ontario or Manitoba, called the Northwest Angle. That's Minnesota. So the northernmost point in the contiguous states, or is a little notch that goes above the 49th parallel. That's where I'm located, a little ways south of that in Minnesota. And I'm drinking fizzy water, passion fruit flavored. But I'm happy to be here with you tonight and introduce you to blower doors. I'm sure some of you are familiar with blower doors. For some of you, it may be brand new. I suspect that, like in the US, how rigorous blower door testing is might depend not only on regulation, but whether the local code officials are excited about enforcing it or not excited about enforcing it. So you want me to jump into telling about the company, or where are we going from here?
Absolutely. Just let's have a little bit of history on TEC, the Minneapolis door, the red door of truth, if you will.
Yeah. So the company was founded in the early 1980s by two Garys, Gary Nelson and Gary Anderson. Gary Nelson is still with us, and he is blower door and building tightness genius. I've been lucky to have him as a mentor. And I took over the company from Gary in 2017. And it's been an amazing ride, learning more about building science. My background before getting involved with blower doors and building science was in measurements of pressure, temperature, level, and flow in a completely separate industry. But it turns out that measuring pressure and measuring airflow are exactly what you need to know if you want to learn about blower doors. So it's been a little bit of a good fit there. I'm also reasonably skilled as homeowners go in the building trades. A couple of years ago, I finished a 20 by 20 addition to my house, and I think I did everything but the foundation and the carpet myself. So I've done a little bit of everything. Took me about 3 years, evenings and weekends. But so I know a little bit about the how the pieces have to come together in building a house. So that's an introduction. And shoot me with some questions, or is this a one-man show and I should get out my tap shoes?
Yeah, Steve, I should
maybe hit us. Go ahead, Connor.
I got a question for you. So now that you've, an expert in the room as far as diagnostics and testing goes.
Yep.
When you built your own structure, this was an addition to your own house?
Yeah. So the house is built in 1958, and I finished the addition in 2019.
Gotcha. So something we hear a lot from renovators and people who don't have the option of improving or building the entire envelope. I'm curious whether when you did your own project, whether you used your tools as a measurement tool when you did your addition to best practice what you're building?
Yeah. So yes and no. I did make measurements, but I didn't get a good measurement before I had started tearing into the house. So I don't have a before, I only have an after. And of course, the after was the entire house, both the old part and the new part all together. I never took the time. I would have required 3 blower doors in the house if I actually wanted to measure how much is leaking from the new part and
Oh,
how
really?
much is leaking from the old part. Yeah, it's hard to do just a part of the house if there's big open ways with no doors.
Sure.
How do you test just part of it? It's possible. I just, it's complicated to measure the air tightness of just part of the house.
Perfect.
But
I don't feel so bad than not testing all my own projects. So
yeah. Well, the other
You
thing
had-
that occasionally people hear about blower doors, and after they've seen a blower door test, or if they own one, when you're doing renovation, it turns out that a really good way to control dust is with a blower door. If you depressurize the part that you're adding on, or if you pressurize the existing part, then none of the dust will migrate from the new part into the old part.
that's really cool, because we use sort of equipment we've sort of borrowed from the asbestos abatement industry.
Yep.
Or they're called, like, we call them neg air units, but that's, I guess, what you're talking about, right? We can depressurize. They're sealed in plastic. They're a bit more robust, but you're right. On this project, we could depressurize or pressurize with that equipment. And maybe that's a way of having a builder also amortize that expense over more than just diagnostic testing their own project. So
yeah.
that's
If you
smart.
do both new construction and renovations, set up a blower door, especially if you've got just a door outside in the addition.
Yeah.
And there's a doorway between them that you can close. That's one thing I will say, is if you want to try and depressurize the addition you're working on, there has to be a door in between them, or you're not going to get any pressure difference.
Super smart.
So I just want to say, Steve, you gained a lot of street cred with every carpenter in the audience when you told them it took you 3 years to finish your addition. Everybody totally gets that, totally understands that.
Yeah.
Because that's sort of like a classic carpenter thing. Like your own home comes dead last.
Yep.
But maybe if you wanted to also like explain what a blower door is and why it works, because a lot of people know what a blower door is when they see it, but they don't really understand why it works. And it's really quite genius, I think.
Yeah. So this is a photo of a blower door test underway. If you haven't seen one before, this is kind of what it looks like. And so there's an aluminum frame that you can't see very well that's holding this red fabric panel in the doorway. And then at the bottom here, there's a fan. This particular test, you can tell that this is a high performing builder because it uses the little fan. If you're building an airtight house, you don't need the great big one. If you're not doing such a great job with air tightness, then you need the big fan. But the way that it works is you put this frame in the doorway. Ooh, Connor's got the high performance model. All right. Yeah, this one we call the mini blower door, and it works on small apartments or, really airtight construction. It moves about 1500 CFM. And so if you're under 1500 CFM at 50, which is pretty good, you could do it with the small fan. But if you're only going to get, one device for all your projects, you're probably going to go with the big fan. So you put the frame into the door like that, and you can't see it too well in this photo, but on the ground, there's a manometer, which is this device over here, right to the left of the doorway down at the bottom. And that manometer is measuring 2 different pressures to figure out what's going on. One is just the pressure in the building. So the fan either sucks air out of the house if you're depressurizing, or it blows air into the house if you're pressurizing. And you have to know the pressure in the house because you're trying to achieve a stable 50 pascals. And once the fan boosts the pressure up to 50 pascals, the other channel of pressure is able to measure how many cubic feet per minute of air is coming through the fan into the building. So if we're pressurizing, that means that all the holes, all the leaks in the house, they're all blowing out. And the only place air can be coming in is through the fan. So if we measure that there's 1,000 cubic feet per minute coming in through the fan, then that means there's 1,000 cubic feet per minute going out through all the leaks. Because if the pressure is not changing, then the air coming in is the same volume as the air going out. And so that's how you measure air tightness. This is how it's done for code, but a lot of builders that are more progressive are doing this during their builds because they want to learn where's the biggest impact on air tightness as I build the house. Now, in this particular test, we can guess that this must be sealed at the roof deck because the ceiling's not in. Normally, if you're doing construction as you would in Canada, I think you'd probably do it more like we do in Minnesota, where usually the insulation is on top of the ceiling, not at the roof deck. And so you'd have to wait till you've got at least the ceiling in to do a blower door test. But once you've got your air barrier in, your windows are in, and your ceiling is in, now you've got all the major components that are going to make up your air barrier, and you can begin to test. And then it's also useful if you're trying to learn, test after the sheetrock's in, after the plumbing is complete, after, more holes potentially have been made. You might find that your air tightness is getting worse over time as, the different subcontractors are drilling holes in your nice pristine envelope. So this is kind of a schematic diagram of what's happening here. This one is showing depressurizing the house. And I'm not sure why this is showing air blowing out of the window. That's actually incorrect. If the fan is blowing out like this, then all the leaks will be leaking inward. So you can see, air is coming in through the attic. It's leaking down through the ceiling, through cracks in the between the wall structure and the foundation, and then the blower door fan is going to be sucking it all out. And as I mentioned, you just face the fan the opposite direction if you're going to pressurize, and then it's the opposite way. People sometimes will ask, well, should I pressurize or should I depressurize? And really, it doesn't matter too much. The numbers are going to be very similar. The one thing that's different is if you pressurize the house, then the backdraft dampers on your exhaust fans for the bathroom, your exhaust for the kitchen range hood, the backdraft damper for the clothes dryer, all those will blow open under 50 pascals of pressure. So you get a little higher leakage when you pressurize usually than if you depressurize. So that's how a blower door test works. And where do we go from here? What's next?
I think you've covered quite a few things. Maybe we should hit some of the. Go ahead, Lori, if you've got an idea.
Yeah, no, I just wondered if you could touch on some of the, in my experience, not having the prep work for, having the site set up well for a blower door test is often, it's a surprise for a builder if they hire an external auditor to come and do the test. And even if you're doing your own test, I'd love to hear your perspective on how to set yourself up for success and just prepping the site and the building.
So the prep is, there's quite a few things on the checklist, and I'm not the best one to give you an exhaustive list, but I can hit the high points, I think. When you do the test, we want the pressure in the building to all be the same. And so all the interior doors need to be open. Otherwise, you can end up with different pressures in different rooms. That's not what you want. You want the whole building to be at plus 50 or minus 50 pascals. And of course, all of the windows and exterior doors need to be closed. Otherwise, you're going to fail. So that's step one. The next step is if you're doing the test at final, when the house is actually ready to roll, now you need to be worried about combustion appliances. So if you're depressurizing, for example, and there's an active water heater in the basement, you can actually suck water heater exhaust back down the flue if it's naturally drafted. So are naturally drafted water heaters permitted in Canada, or is that you have to go with the power drafted or electric? You guys,
They're not permitted in new construction, but if you tour a
Yeah.
house that's, has a mechanical system from anywhere 25 years ago, we see lots of those still.
yeah, okay.
So definitely something to be aware of for sure.
Yeah. So if you're testing an existing house for some reason, you want to make sure that there's, if there's natural draft appliances, if it's, it could be a natural draft furnace, same thing, natural draft water heater, you want to be aware of those. The next thing to be aware of is fireplaces. I suspect that if you guys have a fireplace, that it's not going to have been used on new construction. But if you're testing an old house, just saw a social media post about somebody who learned the hard way that if there's ashes in the fireplace and the damper's open, a big gush of air blowing down the chimney as you depressurize the house is going to scatter ashes all over the living room carpet. And of course, if this happens, the living room carpet will inevitably be white carpet. It's just how it always goes. And so you're going to have black ashes all over the white carpet, and you could end up replacing somebody's carpet. So close the dampers best if there is a fireplace that's been in use to actually vacuum up or at least sweep up the ashes from the fireplace, especially if there's no damper to close on the chimney. But I think that's the high points. Lori, do you know if I've missed anything major there?
So we had a question. Oh, go ahead, Lori.
Yeah, no. I think those are all really good points, and I guess just along the same lines, things like P traps and like anywhere there's possibility of
so I'll mention P traps. So you do want to fill the traps. That can make a difference. Some people wonder if the blower door test is enough pressure to blow a trap out. And the answer is no. 50 pascals is about 0.2 inches of water. So it's only going to cause the P trap to go unequal by 0.2 inches or, just a few millimeters. That's not enough to clear out the trap unless you made a big mistake and went to a much higher pressure. But you do want them full. Otherwise, you're going to be, blowing into the sewer or sucking out from the sewer. That's not a good situation.
Remind me at the end of the show, Steve, and I'll tell you a funny story about fogging a house and smoke ending up where it shouldn't have.
Mm-hmm.
Oh,
when you don't take care of those, those P traps. So travel. Yeah, no,
I
Steve,
was
really
sorry. I was just going to say one last thing. I was going to say we did a blower door test a few months ago on a project, and we were like, we knew there was something, and we couldn't figure out where the issue was, and we eventually found that there was just like a sheet of drywall laying down in the middle of the slab, but it was right where the kitchen is, and it was right where the island electrical feed was coming through. And because there was we were all looking around the perimeter, but you got to check those things in the middle of the slab too.
Yeah. So that's, so Aaron mentioned smoke, and Laura, you mentioned this problem. Now we're getting a little bit into finding the leaks so that you can seal them. And there are a few ways to do that. Aaron mentioned fog, so fog is usually used one of two ways, either a whole lot of fog or just a tiny bit of fog. We make a little fog puffer that's actually made literally out of an e-cigarette and a turkey baster. But it's got some check valves and some fun stuff to make it work properly. And this is for actually when you pressurize the house and you're walking around inside, watching for that tiny stream of fog to go out a leak. And that's a good way to find individual leaks as you're walking around trying to make sure you've caught everything and to air seal it. So, yep, there you go. Connor is prepared. So the other way that fog is done is actually trying to fill the entire structure with fog, and then looking at where it comes out of the house from the outside. And that requires usually a large theatrical fogger like they would use for, theatrical productions when they're trying to cover the whole stage with fog and that kind of thing. Usually the tons of fog approach is, for whatever reason, well, actually, I know what reason, it tends to be used when people start getting lawyers. When everybody gets all lawyered up, that's when you get out the theatrical fog machine. Because if you want to get the dough, you got to do the show. And it's very persuasive when you see fog pouring out of the structure from various penetrations in the building envelope. So the other way besides fog is to use a thermal camera. And to do this, though, you need a difference between indoors and out, which means you either need to do it like early in the morning if the building's not conditioned yet, or you're going to need to wait until there's, heating and cooling in the house. You guys in Canada have lots of winter opportunities like we do in Minnesota. And so once you've got heating in the building, or even if you heat it up with a temporary heater, then depressurizing with a blower door will allow you to see where the cold air is coming in with a thermal camera, because it's going to leave, cold streaks, whatever path that air is taking into the house. And that's a good way to locate the leaks so you can seal them.
Awesome. We have a couple of questions. I don't know if we want to start taking care of some of them as we go.
Yeah,
but
let's do that.
One of the ones was if you're going to use a blower door as a method of dust control,
Yep.
Is there any concerns about the fan motor?
Our fans see a lot of dust, and they do pretty well with it. Construction sites where they're used are typically not very clean. We get fans back from, for calibration or repairs that are just, filthy with dust, and they seem to not mind. So I wouldn't worry too much about dust.
All right.
We've got another one. It's you do want to, if you notice that there's cooling vents you'll see in the motor, if you see that those are getting clogged up with dust, get your compressed air out and blow the cooling vents out in the motor. That's the only thing that's really a concern.
Got another question, and basically they want to know if you can install a blower door in a window or it has to be a door.
So we do, at least we did. It doesn't happen very often, but there's a special frame that's smaller size that you can put in a window. So it can be done. Reach out to us directly, and I can find the details out for you. It's not used a whole lot because, as you know, some windows are egress windows, and some windows are not big enough to be egress windows. And because the fan is a fixed size, not every window can use the same frame. And so if we send a window that's made for frames, you can find, there's windows that are too small to use this frame. And there's windows that are too big to use this frame, because windows vary much more in size than doors do. And so that's why, doors are simpler, because there's a smaller range of sizes for doors than windows.
And one more we have here right now. It's beyond passive level testing. When does the number going lower? Excuse me, I'm just going to reread this. I think what they're trying to ask is beyond 0.6, is there more efficiency if you get a lower number? I think that's what they're trying to ask.
So my understanding is that the 0.6 number that Passive House uses is actually somewhat unique to the particular climate in Germany that Passive House comes from. And of course, Passive House is a very rigorous standard. So if you're trying to be truly passive, requiring very little or no heating and cooling, you need to be really tight. So I think what that means is that in Canada, or in the northern part of the US, that you're likely to, the tighter the better, there will still be benefit, maybe down to, 0.4 or even 0.3. However, I think it's also pretty widely regarded that, once you get below 1, so you're approaching passive house, you're getting down to some pretty diminishing returns. And so, you got to start somewhere. I think you want to look at, what are you building today? Get a few of your builds measured if you're not doing that, and see, okay, I'm around 4 or 5 ACH 50. Maybe I want to be pushing down towards 2 or 3, because I think that can, reap some benefits for my customers. Maybe that's something I want to tout in my marketing, is that, I'm building airtight houses because that's a best practice, and then move lower and lower as you're trying to achieve, very low energy homes like passive house or other standards that are similar to that. I hope that answers the question. And is there nationwide regulation on air tightness, or is it province by province or municipality by municipality? How does that go in Canada?
It's a little bit all over the place.
Okay.
Sean probably has the strictest requirements in Canada right now. Connor could definitely speak to Ontario, but it's basically province by province. And most areas and municipalities don't require actual testing as far as the country is concerned. But there are places that do. But it's coming. Way out west where Sean is, they have the STEP code. The LEAP code is coming for the rest of Canada.
Okay.
And I'm not sure, Connor, is Toronto doing its own thing, Connor?
So surprisingly, no. Toronto is, so Steve, if you haven't heard, Toronto's the center of the world. Just FYI. But no, so in Ontario, there is not a requirement to test, and there isn't. The building code is kind of gray in what its requirement is. It's around 3 ACH at 50, but there are some benefits if you can get at 2.5 ACH at 50 or less. You can actually make some trade-offs in your envelope. So if you hit 2.5 and improve that, you can use a lower performing window. You can use less insulation in your assembly. You can use a lower performing HVAC system. Not the trade-offs you might want to do, but it's kind of a stick and carrot to say, if you can get there and invest in these pieces of your envelope, we'll let you pull back in these other places. So that's the only thing we really have as a mandate.
So is it worth spending a little time to explain what these numbers we keep throwing around are? We keep talking about ACH 50 numbers, but we haven't defined what that means.
Yes, please.
Okay.
Absolutely.
So most of the building codes are written not in terms of cubic feet per minute, which is, what the fan actually measures. The fan's measuring cubic feet per minute of air going through the fan. And if you think of a cubic foot is about the size of a basketball. So you can sort of think in your head to wrap your brain around that, if it's 1,000 cubic feet per minute, that means there's 1,000 basketballs worth of air going through the fan each minute. But because we make small houses and medium size and big houses, we need a way for the building code to say we want them all to be airtight, but we understand it's not reasonable for a house that's 4 times the size to meet the same number of cubic feet per minute as a tiny house. So what we do to equal everything out is we say, well, we're going to take that leakage volume of, say, 1,000 cubic feet per minute. Now, are you guys using CFM, or should I be talking cubic meters per hour? What's the code written, or is it just air changes?
Most of us understand CFM.
Okay, we'll stick with CFM.
I would stick with that.
Okay, we'll stick with CFM. Like, I never quite know when I cross the border what's going to stick in American or US units and what's going to go metric. So it would take that 1,000 cubic feet per minute that the fan measured, and then we divide that volume of air by the volume of the house. And then, we need to switch from cubic feet per minute to air changes per hour. So there's a divide by 60 there. But if you take the volume that went through the fan and divide it by the volume of the house, that tells you air changes per hour at 50 pascals, and I usually abbreviated as ACH 50, air changes per hour at 50 pascals. So that way, if you have a really large house or a really small house, they're both going to turn over the air the same number of times at 50 pascals, if you're comparing a blower door test to a blower door test. The important thing to remember, though, is that the ACH 50 number or even the CFM 50 number that you test, that's not how much air leaks through the envelope in normal conditions, because the test pressure is much larger than the pressure that you normally see inside a house. Normal leakage pressures are going to be 2 to 4 pascals, but you're going to test at 50. So we test at 50 just because if we tried to test at 2 to 4 pascals, we'd never get anything done because the wind pressure is often much larger than that, and you want to be able to test on a breezy day still. So, yeah.
So Steve,
a little bit of wind on the island, Aaron.
just to follow up there. Is that safe
Uh-huh.
to say then? I mean, I'm a builder background, not much in science. Is that safe to say then, if you have a number at ACH 50, let's say it's 3 air change per hour, and normalized pressures are between 2 and 4, let's just pick 2, that I could divide that ACH number at 50 by 25 to get my normalized leakage at my normalized pressure rate?
Nope. The math is, you can calculate it, yes, but the math is not quite that simple because
Okay.
there's an exponent that's not 1. It's not linear. So almost that simple, but it's a little more complicated. You have to use an exponent of 0.65. So the best way to do it is, we've got software program called CStack that helps you actually see and understand the leakage in a house. And that will allows you to move this temperature slider around and change the leakage of the house that you measure with a blower door and make it taller or shorter, because all those things are going to affect how much it actually leaks in everyday situations.
Interesting. Yeah, I find that's what clients ask about. They're like, wow, that's a big number. My house I tested, I have a 1910 house in Toronto. It's parts been renovated, parts are really not, and it's at 5.5 ACH.
Okay.
And that sounds like a big number, right? 5.5 air change per hour. So under that pressure, the volume of air turns over 5.5 times, which seems like a lot to a client. But then they ask, is that the real number? And it's been hard to answer that question before. So thanks for that. I'll have to dig into CStack.
Yeah. So there's a podcast that I recorded at the beginning of COVID, I think it's April or May of 2020 if you go to the Energy Conservatory YouTube channel and you scroll through them in chronological order, you'll see April or May of 2020. There's a webinar that I did about how buildings leak, and I walk you through this CStack program because it turns out that it's very, very complicated to know how much it leaks. It depends on the indoor temperature, the outdoor temperature, how tall the building is, and we don't even get into wind because that's too hard to model.
Gotcha.
That is totally fair. We've got a couple more questions. I'm going to say this question is, what's the largest number of blower doors you've set up on a single building, and what was that building?
We were involved in a large, there's 2 that I know of. Both were distribution warehouses for a large retailer that I won't name. One was in Spain and the other one was in Washington State. Both of them were more than 25 fans. The one in huge warehouses like loading docks. I think there were like 35 loading docks for semi trailers, and big warehouse and storage, loading and unloading. And that one, I actually didn't use all Minneapolis fans because that one was so big. There's a manufacturer of blower door testing equipment that is almost gone, except they still make this enormous fan. They don't make it anymore, but there are a couple of them in existence, fans that move 60,000 cubic feet per minute. So there were 2 of those plus 25 Minneapolis fans to test that warehouse. And the one in Spain, I think, was 32 fans, and those were all Minneapolis fans.
Well, that's it. That's
Wow.
actually really interesting because I was at the tallest passive house tower presentation center yesterday, and so that building's supposed to be completed in by 2029. So it'll be neat to see how many that they put into that 60-story tower. So that's going to be
Yeah.
it's going to be interesting to notice. But I'll use that stat next time we talk about it. Being, can anyone guess how many blower doors RDH is getting ready to use on this project? Because I'm sure there's going to be many of Energy Advisor that they'll be boring blower door test for that particular one.
So I'll give you some fun statistics on another one that took place in Vienna, Austria. That one I think was 40 or 60 stories tall,
Yeah,
something like that. What's that?
It's the bank.
Yeah, and it was very tight. So I think altogether it just took 6 fans. But the statistics that are crazy is it took them 7 hours to prop all the interior doors open. And they had 4 milk crates full of door stops that they had to wander through the entire building, prop over. It was an apartment building that's like 40, 60 stories high. And it took them 7 hours just to prop all the doors open so they could do the test. And I think they had like 4 fans on the ground floor, and then 2 more halfway up, and then 2 more on the top floor.
Yeah. And then getting them all synced up is just such an interesting thing. So
Yeah.
No,
Yeah, it's not simple. You're talking complicated stuff.
Well, we're getting on in time. We're not out of time, but before we open the floor to questions, there is one other question in the chat here that was something I had hoped we would cover, and that's like, when do you do a blower door test? When's the best time? Like, everybody knows the final, like at the end you do the blower door test, but
Yep.
as a builder and a carpenter, I know that really it's too late. Like, you get a number, but it doesn't really teach you anything.
Yeah.
So maybe if you could elaborate on that, Steve, that would be awesome.
Yeah, I think it depends on what you want to learn. And since I'm talking to builders, I would encourage you, consider getting your own equipment, or, even better, find a buddy with equipment. It's kind of like swimming pools. You don't want your own swimming pool. You want a buddy with the swimming pool, so he has to take care of it. So, see if you can get your hands on a blower door. And I think it's best to test throughout the process. As soon as you have windows, doors, and a ceiling in, now it's not too early to start testing, and you're going to learn something. Because, then once you get your, the plumbing penetrations are completed, and, I don't know, there's probably different orders that you can do stuff in, but that's not too early to start. And that's really, as soon as the air barrier is complete, that's the best time to test if you're trying to learn, because that's when it's easiest to fix everything. If you wait until final and sheetrock's in, and there's no seal between the house wrap on the outside and the ceiling on the inside, well, that one's pretty hard to fix after the fact, especially if there's already siding on the house. So I would encourage you to do it several times throughout the process and learn as you go. Work with if your insulation subcontractor is responsible for the air sealing, maybe test before they start, and then test after they've got the vapor barriers all in, and the everything's all bats are in, and or however you're insulating, and test after they're done if they're responsible for that. I will say that the biggest bang for your buck, if you're not doing any air sealing today, is the sealing. CEILING, not SEALING, because a lot of people, when they think about building tightness, they're thinking, oh, it's my windows. Well, it's rarely windows these days. Old single pane windows, sure, maybe. But modern double pane windows, triple pane windows, they don't leak very much. The leaks are usually where the foundation meets the wood framing, or where or at the ceiling. So one of the most important leaks I'll mention, and that is between the top plate of a stud wall and the sheetrock. So you think, that's screwed on there. That's not leaking, but there's, a 1/16 or a 32nd of an inch gap in between the sheetrock and the top plate. And you think that's nothing, but now in your mind, I want you to add up how many linear feet there are of that leak. It's only a 32nd of an inch wide, a millimeter, half a millimeter, but all the interior walls included, because those will leak air from the wall cavity into the attic behind the sheetrock, and the front of every wall and the back of every wall. So in a typical, even a modest house, there's probably hundreds of feet times a 32nd of an inch. That ends up being a pretty big hole. And then all your electrical penetrations where, the electrician drilled through the top plate to run the wiring down from the attic into the wall, all those, they'd much rather drill a 3/4 inch hole, even though a 1/2 inch hole would do it. And they don't go back with spray foam or anything to fill in that hole, where the plumber knocks out the top plate, because knocking out the top plate completely is easier than drilling a hole in the top plate. Well, that's a pretty big hole around the pipe. So I'll mention another one that's is what we like to call a FROG, or finished room over garage, is a fun acronym. There is FROG, finished room over garage. And what's tricky about those rooms is very often when they finish a bonus room over a garage, there's knee walls that divide the room from the attic behind it. And those knee walls go from the roof rafters down to the subfloor. But if you think about it, what's under the subfloor where that knee wall goes down? Usually it's a wide open joist space. So that means that you've got this, huge opening between the triangular attic behind the knee wall and the floor under the bonus room. So that bonus room tends to be one of the leakiest parts of the construction if you're not doing anything to seal the gap in between the floor joists, between the knee wall, between the subfloor and the ceiling below, into the garage. So that tends to be a real leaky one. There's actually quite a few things you could do that are fairly low-hanging fruit if you're not thinking about airtightness, to really up your game. If you know where the big leaks are, for probably, like a couple of $100 of caulk and spray foam, you can cut your leakage to less than half if you do it at the right time, and maybe it takes an hour or two. It's really not that hard.
Yeah, I think those are all really valid points. Is around testing. It makes me think about that room being called a penalty room, because you're just penalized for the leakage in the pour assembly. And also, if that's in master bedroom, which is common, how do you put plumbing in that floor? But that's a different debate. I think a lot of builders, and I'll put myself in this package, because we used to hire for certain projects only who had performance goals. A energy rater would come in and help us understand how it hit, required metrics. That was really great, but that was only, once in a while in our projects. But yet we would go and spend hundreds and thousands of dollars on tapes and membranes to do, tight work. But without testing, we really didn't know where we were using these materials appropriately. And we had, I think Hammer and Hand is a beautiful company to publish their details. We would recycle the same details on many projects. And until we start testing our first projects, just what we call a normal project, to know how we're doing, we had no assessment of knowing what details we do in-house work and which ones do we need some attention. And I think to use your equipment and to use this equipment to test a few projects as you go, to really learn what is working, what's not working. Yeah. So if you were training your carpenters, your apprentices on your method or your best practice, you don't really know until you actually see it under pressure, under fog. As you're saying, normal pressure is 2 to 4. Under that accentuated pressure of 50, to really show you where you're succeeding. I think it's a really wonderful tool for all projects.
Yeah. So Aaron mentioned that you guys are the land of 6 mil poly, and that's what we do in Minnesota, Illinois. The northern states do the same thing. So I'll mention a couple of details that I did on this addition that I put in the house that I think are fairly simple and really improve the air tightness a lot. So first of all, my air barrier was 6 mil poly on the ceiling. And so around each of the electrical boxes, you've got to cut a hole in the vapor barrier to get that electrical box through. What I did is I just took my razor knife and I cut, a star, three cuts. So you end up with 6 triangular flaps, and then push that star over the light electrical box. And then I just took electrical tape and taped those flaps to the electrical box up about a ½ an inch, so that when I put the sheetrock in, it was going to stay in place. And when I, roto-zipped around the light fixture, the tape was going to keep the vapor barrier from getting shredded and losing that seal. So that was a fairly simple approach there. The other thing I did is where the poly wrapped down, from the ceiling onto the wall, I just put a bead of acoustic sealant on the top plate. And the reason I used acoustic sealant, if you haven't used this stuff before, it's really gooey and really sticky, and it stays soft. And I wanted that because I didn't want any lumps in the caulk to make my sheetrock not lay flat. And also because it remains sticky, it will stick to the poly, until the end of time. Whereas if you use something like silicone that cures, I think the poly would peel off of silicone pretty easily once the silicone was cured. But acoustic sealant remains sticky. So I ran a bead of acoustic sealant around the top plate, and then I stuck the poly to the acoustic sealant. And I just did that all the way around on, both sides of the interior walls and on the inside of the exterior walls, so that the poly was now sealed. And there, that leak, like I mentioned, between the top plate and the sheetrock, it's not going to let air flow from the wall cavity up into the attic anymore. So that's just a fairly straightforward thing you can do. And then I went, just used regular spray foam from a can to seal around all the plumbing penetrations and the electrical penetrations that go through that top plate. Because you remember that the wood in the top plate and the sheetrock and the poly, that's what's going to prevent air from making its way through the ceiling. And you can't just think about, the sheetrock that's in the room, because you don't want leaks from the wall cavity into the attic either. Because remember, your sheetrock's also not sealed at the bottom. So if there's a leak at the top of the sheetrock, it's actually going to suck. Air's going to go in behind your baseboard, behind the sheetrock, into the wall cavity, and then into the attic. That's the path that it will take, or it'll come out the, the electrical outlets, down at the bottom of the wall cavity.
Well, maybe so we don't go into too crazy of an overtime, we should open the floor to questions. I know Peter had a question, and he's a good friend, so we should probably let Peter weigh in and ask his question.
There you are. Just wondering if there was a simpler version of the whole lower door assembly that would allow firefighters to evacuate the smoke from the building. So just one with no metering and just the fan and the frame.
So not that I'm aware of, but that's, not a bad idea, because, a lot of people figure that if I open the door and put a fan in the doorway, that's going to get the job done. But if you don't seal around that fan, much of the air you blow is just going to come back out, or it's going to go back in, depending on which way your fan is facing. And so you really do need that panel that we showed in the blower door in order to pressurize or depressurize the building. So I do know of something that's similar to what you asked, but it's normally a permanent part of the building, Peter. And that is, in any sort of a high-rise building, there's usually fire code requires a smoke control ventilation fan to be put either in the top or the bottom of the stairwell. And that's hooked into the fire alarm system, so that once smoke or fire is detected, that fan turns on and it pressurizes the stairwell to a known pressure so that people, evacuating the different floors, if they make it to that stairwell, that fan's going to keep the smoke from accumulating in the stairwell, at least, not in the rest of the building. But and that's one that I'm aware of. It's similar to what you're talking about.
Had occasion this summer to have, well, a neighbor of mine, there was a fire in the backyard in the fence, and the smoke got in the house through the unused fireplace venting.
Oh,
And they put, just large circle fans at the doors. But as you said, it just circles back and doesn't have effect. So I was speaking with the firefighters. Do they know of such a thing? A few of them knew about the blower door.
okay.
But, it's just somewhere, for you, it's for marketing. I mean,
Yeah, I'll mark that down as a marketing opportunity. But yeah, like you say, there's a very big difference between just putting a fan in an open window and a fan in an open doorway. That won't create any pressure because the rest of the open window or doorway lets the pressure out. In order to actually build pressure in the building, you have to block off the rest of the window or block off the rest of the doorway. That's why a blower door has a panel, is because otherwise you can't get any pressure.
that was my observation at the time of the neighbor's fire. And it took a while for them to, do that. They just put fans, they have those mechanical fans.
Yeah.
For the purpose, but it's not effective. And I just wondered if this was a way to go that's better for the fire departments anywhere.
Yeah. The other thing I've considered along those lines is people that are, in the Western states, Western provinces, when they've had wildfire problems. If I lived in an airtight house and I had a way to pressurize my house with using a HEPA filter to pressurize, HEPA filter the air and then blow it into the house, that would prevent any smoke from coming into my house at all, because all the air would be coming through that HEPA filtration system. And that's only possible if the house is reasonably airtight. Otherwise, you'd have to move a ton of air through a HEPA filter and it wouldn't work. But if you build the house airtight, then you'd be able to pressurize it with a reasonably small fan through a HEPA filter and, have a pretty smoke-free house, regardless of what's going on outside.
Cool. I know we've got a few more questions. I know Jeremiah has a question, and I know Leo has a question. And I may have missed a question. So if I have, chime in right away, and we'll make sure Steve has some time to answer them. Jeremiah, if are you still with us?
Yep, I'm here.
Perfect.
I jumped in kind of late, so good afternoon or good evening, everybody. But I jumped in a little bit late, so maybe this was sort of talked about at the beginning of the presentation, but just a little bit curious about using a manometer for other purposes other than, managing a blower door, and in particular to balance an ERV or an HRV. I do have access. I'm in kind of one of those shared situations. A friend of mine and I share the pool. So playing around with a blower door has been a lot of fun. We've been using it at various stages of projects just to learn it and sort of see where we're at. But our mechanical contractors generally do very little to check balancing of an ERV or an HRV. And since we have access to this equipment, I feel like, it'd be an opportunity to learn a little bit about that if I can use something like that to sort of get a sense of where the machine is sitting at.
Yes, there's kind of two ways you can balance the ERV. The first one is just to turn the ERV on and see if it changes the pressure in the house.
Mm-hmm.
Because if it does change the pressure in the house when the ERV comes on, that means that inflow and outflow are not balanced.
Right.
However, a small pressure difference on a windy day is going to be hard to measure. And so usually what's done by energy raters is they will measure the airflow coming in and the airflow going out with
and the ports at the core.
The what?
Via the ports, like the test ports
yes.
at the actual core.
Yes, some manufacturers put pressure ports on the core that you can use to measure the differential pressure across the core, the outflowing and the inflowing, but they don't all have that. And
Yeah.
so if they don't have that, then you have to have a flow hood to measure the airflow coming in and the airflow coming out at, wherever it goes out of or into the building.
Yeah, and I realize that test at the unit is just simply checking the balance right there at the unit. It's not really telling necessarily the whole story in terms of how the duct system is connected to it and what kind of flow you're actually getting,
Yeah.
further down the line and versus into here. But I was just curious about that. Thank you. And just one last comment when you're talking about vapor and air barriers and ways to detail that in that 1/32 gap around the plate and those kind of things. For us, the by far the best approach we've found over the last few years is just integrating service cavities so you can have a continuous barrier across your ceiling or walls and sacrifice that tiny bit of floor space or a little bit of ceiling height just so you can keep that membrane continuous. Can make that job really easy and almost foolproof at that point. Very little penetrations through the barrier at all. Appreciate your time.
Yeah. So I'll mention another thing that's fun to do if you've got access to a precision micromanometer, a blower door style manometer. I'll just explain the problem. There's a problem fairly common in American homes that happens because certain systems will have a central filter grill return where all of the return air goes back to the HVAC, typically in a hallway. And when you do that, you need to make sure that there's a pathway from each of the bedrooms that has a supply register to get back to the filter grill where the air returns through the system. And it's very common that there's not enough return air path. So, and if you put a manometer under the doorway of the bedroom door when the HVAC is running, and you find out, oh, that bedroom is pressurized by 8 pascals, that's a problem. That causes additional infiltration beyond what would normally happen just from wind and temperature difference. And it can cause, damage to building materials. If there's humid air, it causes comfort problems because when you close the door, you're getting less heating or cooling than when the door is open. So if you have central return type systems in Canada, measuring bedroom pressures is a fairly common building and comfort problem that you can diagnose with a simple manometer. Typically, the threshold for that one is you don't want any rooms pressurized or depressurized more than about 2 pascals when the HVAC is running. And the solution is either need to make the undercut on the door bigger, let the air out under the door, or put a transfer grill in the attic that goes just from the ceiling in the bedroom to the ceiling in the hallway so the air can get back out. That's how that you solve that problem. That's something that your HVAC subcontractor should be aware of, but probably isn't.
Steve, just to jump in there, I think that's super smart. And it makes me realize that, growing up, and maybe this is more carpenters too, is it's usually that little decision about how much the doors undercut was left to the trim carpenter because they installed the door, they flush cut the door, they might favor a darker bedrooms, they pick 1/2 inch or 3/4 in. We just did a project, and based on the size of the master bedroom, the HVAC design called for 2 1/4 at the door, which won't work.
Yeah.
It made us realize we need other solutions. But
Yep.
without actually looking at that with what you're talking about, that would have made an uncomfortable room in a very fancy house. And it's why really the whole trade and the whole building needs to know how the system works. And these decisions are not, left by chance, and we should measure.
Yeah. And so the flip side of it, if you have all your bedrooms pressurized because they have a supply and they don't have a return, well, the flip side is the whole rest of the house has to get depressurized because it has a return and not very much supply. So all your bedrooms go positive pressure and the whole rest of the house that's connected to the filter grill or the return grill, that all goes negative, which means you're sucking in air through all the leaks more than you would just from temperature and wind.
Wow, fascinating. Sorry, my mind dropped. Leo has a question.
Hey guys, as
Hey, Leo.
usual, at my job site desk.
This is my favorite part.
I'm flattered. Comment just to what Connor said. Growing up in Vienna, Austria, I'm obviously pleased to hear about that phenomenal blower door test there.
Yeah.
But also hydronic heating is fantastic because it's quiet and you don't actually have those problems. I remember coming to North America and thinking, Christ, these people, they really don't value privacy, do they? They've all got these ginormous undercuts into the doors, and if like in European homes, every indoor interior door has a gasket seal around it, right?
Yeah.
Which just, and I was like, what is with this? And it was my building science, if you will, and HVAC education, then bit by bit, where I was like, oh, now I understand why these whole undercuts are there. It's just for airflow. Like I didn't
Well,
realize that.
there's
For
another
maybe for a long
solution.
time.
Just so you're aware, there's another solution, and that's to put a return in each room, and that's commonly
Well, and
done.
that was
Yeah.
that was the other point I was going to then bring up is that that's sort of the only way, if you will, to solve for that.
Yeah.
But obviously you run into the issue from the whole planning and design thing of running ductwork.
Yeah.
My question is about if we're already having sort of the accumulative effect of a 32nd at the top plate. What is an accumulative effect of the staples, if you will, going through your vapor barrier? And the other thing I was thinking is how, and this is to everyone else here, is how do you prevent your drywallers from shredding your carefully applied vapor barrier, unless of course you in situations where you can't have the service cavity, which I realize the service cavity is the way to go. We in this renovation here did not have an inch to spare, because the thing I was thinking is if a drywall screw goes through the vapor barrier, but there's drywall and wood, then it pinches it tight. You're not going to get any airflow through that.
Yeah.
But if the drywaller misses, you have, with pressurization and depressurization, you've got the billowing, if you will, even behind the drywall. Like if you've got pressurization of the house, the air barrier would go out from the drywall, so it could pull off of that screw that is poking through, and it might not go all the way back.
Yeah.
Is that a thing?
So screw holes, my understanding is screw holes and the staple holes matter very, very little, because if you start doing the math, a 32nd of an inch times 500 feet is actually way, way more open area than even, several hundred staple holes. Or as you mentioned, let's say they missed 25 screws and they just left a hole. 25 screw holes is still much smaller than a 32nd of an inch times 500 feet.
That's very reassuring to hear, because otherwise,
the other thing, the other thing is that I'll share with you, because this is a kind of a revolution that we went through in Minnesota and other Midwestern states that have a similar climate to a lot of Canada, is that you don't actually need the 6 mil poly on the inside if there's a vapor retarder somewhere else. So let's say your air barrier is a house wrap on the outside, or it's zip sheathing. You've got a coated sheathing with tape as your air barrier. If that's the case, you only need a vapor retarder, and typically latex paint on sheetrock is enough of a vapor retarder to meet the code. And so, once you're thinking about air tightness more completely, that vapor barrier ends up not being necessary anymore.
Okay. In this case here, it's a late 1800s house, so my vapor retarder is also my air barrier.
Yeah.
So
that's when you start getting into smart vapor retarding membranes and stuff like that. Yeah, that becomes useful. On the addition that I did, they're very nice. On the addition that I did, I put poly over the ceiling sheetrock, but there was no vapor retarder in the wall other than latex paint on the sheetrock. And that, code official was fine with that because I was all taped and sealed on the outside. One interesting kind of building science principle that I think is worth sharing is people sometimes get really concerned about vapor permeability and perm ratings of barriers and stuff. But when you actually have condensation, damage, and moisture accumulating in a wall cavity, air leakage is typically going to carry something on the order of 10 times as much water into the wall cavity as can pass through the building materials, regardless of what they are. And so that's where, air tightness is way more important than getting the perm rating right on your barrier.
Right. Something I thought of also, maybe I can quickly show that it's still visible. One trick I applied here, not sure if it's visible, but I took some CPVC I had lying around and threaded my electrical stuff through that because it's easier to seal my vapor barrier to that. Can you see that?
Yeah, we can. Great detail.
Okay. And then in the I can push that up as long as I want, because then if I really want, I could push that up above my insulation in the attic. And it's easier to seal the individual wires to the actual small little pipe, or I could just fill the whole pipe with spray foam if I so desired.
Yeah.
Right.
Yeah, that's great detail.
That was just something I figured is, I don't know. I was trying to think ahead also in terms of repairability, and fishing wires through anything with spray foam, or trying to dig something out of spray foam is always fun.
Yeah.
Question for the others? Do you guys mark with tape or spray paint or something on the vapor barrier, or like on the Intello, for instance, if it's not translucent? Do you guys mark out where the studs are, or where drywallers can screw and can't screw?
Yeah, we typically do that on the floor. So before we do the drywall, we'll spray all the important things. So we'll label electrical items, plumbing, and so when we go to do drywall, that we make sure we cut them out, and it's a reminder. So yeah, my floors in our job sites get heavily marked with spray paint and color coded. And then we get a bit crazy where we even label them, where you'll see, E's and G's and sprinklers and a whole bunch of stuff, just to make sure we're crystal clear what's happening behind the walls, because we take thousands of photos before we insulate and drywall, so that if there's any repairs needed during construction or well after we leave, that the homeowner knows exactly what's behind there.
What would you do
Speaking
in a situation
as
like this, where just because it's an old house, things aren't necessarily in line? So if I spray paint down on the floor, the drywall is going to go up, but then all of a sudden everywhere here he's going to be missing.
So let me ask you this, Leo. Are you doing the drywall yourself, or are you subbing it out?
It's being subbed out, and I'm standing behind them with a whip.
So you're going to be present.
Let's put it this way. I'd like to not have to be, but I'm too terrified, if you will. I've put too much work in here to not micromanage to a certain degree. And I know I need to tread carefully to not overstep. It's a very fine line. And I'm just trying to, I guess what I'm trying to say, I'm trying to think of strategies that I can make their life as easy as possible, so that I can just, in Austria we still have conscription, and so in the army we used to call things like that, when things were made soldier safe.
Yes.
Yeah.
It's a different way of saying idiot proof.
Yes.
Yeah.
I appreciate that.
I got a suggestion for you. If you have some amount of confidence in your drywaller, then I would take the trust but verify approach. And in this case, what I would do is, leave it to the drywall to notice that ahead of time, but trust but verify. So you're going to take a couple of photos of how they're not lined up. And then when you go in after the screws are installed and you see that all the screws don't go over, 3 inches, then you're going to take out your photo and you say, you missed all the studs on the ceiling.
At the moment, my trust is limited.
Fair. Yeah, we're already at that stage.
I'm curious if you did a similar detail on those boxes to what I did, Leo. Do you tape the membrane to the electrical box so that it gets shredded less when they rotozip?
No, I mean those are those metal plates with the hole in there, and then let's see, where's that? Oh, right. Electrician, also might need a bit of education, because you sort of ask yourself sometimes, this is what it looks like, I guess, on top.
Yeah, okay.
Right. So
okay,
I still need to follow up right now with some, I was going to just use the Tescon-Vanna tape on this, or whatever, and seal it. But you sort of ask yourself sometimes why they are even like going to the trouble of, I saw him walking around the job site, carefully taping the plastic to this, but then they punch or cut a huge hole in that, and it's sort of over on this one. You can see the tape is already just from dust, it's just delaminated, or just come off completely. So I'm not quite sure how I'm going to solve for that. My thinking was maybe take an afternoon and make a whole bunch of MDF boxes to put over that after the fact, like just come up here into the attic, and just use the what is it, the Proclima sealant, the green stuff,
Contiga,
Contiga, yeah, and basically just seal the, kind of make sort of I don't know, some kind of a thing that goes over the top of here with a slit or something, so that you can still get it on without taking the wire off. Coming up with some system, or it might be, maybe that's worth a good trip to the dollar store and just get a whole bunch of dollar store Tupperwares or something like that and seal those to that.
You can seal that up. It's a bit of work with tape.
Oh, for sure. One thing I can recommend is if you know roughly where your insulation level will be, is to build yourself a gangway, because after the fact it makes working up here a lot nicer.
So my rule with blue tuck tape is apply it once to remove dirt and dust, then reapply it to actually adhere. Unless it's a pristine surface, any tape's going to fail if you don't have a clean surface to work on.
I typically try and always have a bottle of isopropyl alcohol handy, like on anywhere I go, actually. It's just too handy. If you cut yourself, you could disinfect a wound. If you need to clean something, if you get Sharpie on something, it's just good to have around.
So the one possible exception, I don't know how many of you used the 3M window flashing tape. I've heard it said that stuff will stick to air. I didn't have somebody to hold the end of my tape measure, and so I took a piece of that tape and I stuck it to a dirty piece of cinder block that was on the outside after excavation. It never came off.
Yep.
It stuck to the dirt and the concrete, and it's still on that house.
All right. Well, I'll keep that in mind.
Yeah.
Steve, quick question before we wrap up here. For those of us that are interested in finding equipment, learning more about how to find and buy a blower door set or kit, how does one do that? Do you work through distributors? Do you go to
we have one distributor in Canada called Air Solutions, outside Toronto. They're very good. I know that we also sell stuff direct. They don't seem to have a conflict with that too much. I would reach out to Air Solutions. They've been very helpful. You can reach out directly to us if you want. On our website and especially our YouTube channel, we're getting more and more content that is, look for some blower door basics, how to do the test, look at our website for pricing and guidance. I will say, if you're just trying to dip your toe in the water, at least in the US, there's a fairly robust market for used blower door equipment. And even our older DG700 manometer, that we made tens of thousands of, they're still in great shape. Aaron's shaking his head because I know he grew up on a DG700, and they can be had a lot cheaper than new equipment if you just want to dip your toe in the water and check it out. We continue to support and calibrate and repair, if we have parts, any old equipment. So
that leads to,
yeah.
Sorry, Steve, that leads to a question that got buried that I was trying to find, and somebody asked quite a while ago. When do you recalibrate a fan? When do you recalibrate your door?
Okay, so the manometer needs recalibration. The older one, that's the square cream colored one, the DG700, that needs to be calibrated every 2 years. The newer one that's got the touch screen and it's black landscape orientation, that one needs calibration every 4 years. And generally, we don't have a strict calibration interval on fans, but you will find on our website there's a field checking procedure. And you should do that, once a year, that you're just making sure, because there's nothing electronic in the fan that can drift really. So as long as nothing is cracked or the tubing inside that connects your pressure sensor to the flow sensor of the fan, as long as nothing's cracked or leaking, the calibration just doesn't move on the fans.
Steve, I have a short question for a friend who's here. They wanted to know, are the numbers on your fans sequential?
The serial number on fans, yes, is sequential.
They are, okay. I have some colleagues here. So Austin Todd is an educator with me at GBC, Georgetown College, and has some older fans, he said, in the thousands. I was trying to figure out whether those are, yeah, I know, right? That sounds like old hockey cards. They sound like valuable
right?
and precious, right? So that's awesome.
Yeah, that's an early one. That's good stuff. I will tell you, we did a friend in New Jersey had a really old manometer that was 22 years old and hadn't been calibrated in 19 years or something. And he sent it in for calibration, and we found, 2 points were slightly out of calibration after 22 years or 19 years or something. So
I might get lazy then. Careful, you shouldn't have said that.
Yeah, honestly, for what you're doing, don't sweat it if you don't get it calibrated every 4 years or every 2 years. The equipment's very stable. And there's a field checking procedure for the manometer as well, because there's two different sensors and they're independent. The easiest way to check it is just to apply the same pressure to channel A and channel B. And if they read the same, they're probably good. They'll drift a little bit over time, but it's usually nothing serious.
The best way to deal with this situation is the friend you've been letting use your blower door, tell them to get your own. You go to the same house, you do 2 tests. If you end up with the same numbers, you're good.
Yeah. No, so I think the friend who's been borrowing your blower door, you sell him your old one and you get a new one.
Yeah.
Even better. Even better.
Yep.
All right, Steve, I got a question for you that kind of goes back to the beginning, almost 84 minutes ago. You're talking about the kind of creation of energy conservation is Harold Orr. We think that Harold Orr created the blower door here in Canada. Can you see if there's some collaboration, some American-Canadian collaboration in the early adoption of blower door?
I think I've heard of Harold. When was Harold Orr doing blower door tests? Do you know?
So he created the Saskatchewan house in 1972, and so there's the discussion that they were doing blower door test or a type of test on that. Maybe not the right sensors, I think, are working. So I'm wondering.
My understanding is he's way early, but the Swedes had us all beat.
Oh,
It was, I think,
Interesting.
blower door testing became mandatory in Sweden in like 74 or
oh,
something. So, there was clearly a mature market for the equipment, long before that. And I don't know the history, but I do know, I've heard the name of Harold Orr, and I think he's one of the early pioneers, but probably
I can talk about Harold Orr just really
Okay.
briefly. I wish, like, I don't know, 8 months ago, I gave a workshop in Saskatoon, and at the end, somebody said, "Would you like to meet Harold Orr?" And I was like,
Wow.
"That's the reason why I'm in Saskatoon." Um, and so he met me at a mall, and he showed up. I don't know how old he is, approaching 100. He's,
yeah.
very elderly. And he had a huge binder. And he just like opened the binder and started showing me stuff. And he did tell me the story about the first blower door test. So before they had this, they would actually fill a house or a building with like helium and then do testing of the concentration until they knew, like, until it was all gone.
Yeah.
But he told me that he built a blower door apparatus out of sheet of plywood and a fan that he bought at Princess Auto. And he sawed it into 3 parts and put piano hinges on it so that he could fold it up and put it in the trunk of his car. And he used it on a whole bunch of buildings. And then he said the Minnesota blower door company came knocking and took his idea. And because he worked for Enercan and the National Research Council, everything he did was basically he couldn't keep his IP. So he was using it for, he said, and he's however old he is, it was a long time ago. He was using it for a number of years before it kind of caught on.
Yeah.
Great story. Yeah, I was
Yeah,
looking
so-
at the map and I figured, that little part of Minnesota that sticks up into Canada, I'm sure they probably met at like Angel Inlet, where a
Yeah.
fair trade could have been had. So
Yeah, right. But yeah, so our founder, only goes back to, I think his first blower door was in the early 80s. So yeah, it's not as early as Harold Orr for sure. But a lot of people still, because we've been around so long, think that Gary Nelson, our founder, invented the blower door. And he's always clear, no, I didn't invent the blower door. But we like to say, if you're into automotive history, Carl Benz made a car long before Henry Ford.
Yeah.
But we say, Gary Nelson is not the Carl Benz of blower doors. He's the Henry Ford of blower doors and like the Model T. Gary realized that it needed to be much simpler and much cheaper than what was available in the 70s. He did his first blower door test, and it was like, tens of thousands of dollars to get the equipment, and it took all day to do a blower door test. And he's like, there's got to be an easier way. So Gary was driven by, I can't afford one of those. Maybe I can make one. And a couple friends said, well, can you make me one of those? On his third try, it actually worked out pretty well. And it grew from friends wanting, can you make me one? And that's where, it became, not so much a research tool as something that everybody could do easily.
So how come the red paint versus the black, if we're talking cars then in Model T?
Yeah.
Honestly, Sean, this was my question exactly. I was going to use this to wrap things up.
All right, well, I'll let you wrap it up.
But seriously, this is part of the reason that, we think Harold had something to do with it, because red door, Canada, red is our color. Just saying. But seriously though, why the red door?
I don't know why red was chosen. That I'll have to ask Gary that question. It was so that, Mark Willey and others could many years later call it the red door of truth. That's why they chose red.
Little foreshadowing there, but yeah. Well, if you find out, Steve, please let us know.
Yeah, I'll
And
ask Gary
we'll pass it on.
why red. The only thing I can think of is just so so it's for safety, just like walk into it.
But then it would
Yeah,
be green. This is the whole thing about fire trucks and safety is difference of lime green versus red. That's why airports have lime green fire trucks, not red, because of human eyesight. But anyhow, we segue. We should probably wrap
Yeah.
it up. Aaron.
We should. We're a half hour long. Steve, thank you for joining us. A lot of great information, and hopefully a few people got some great takeaways. And
Yeah.
if you have questions, reach out to Air Solutions or Minneapolis
Yep.
Blower Doors, TEC, the Energy Conservatory, and somebody will have answers for you. Or get a hold of one of us.
Yep. Jake McAlpine does most of our tech support. He'll pick up your call. He's super knowledgeable. And we don't say no, even if you're Canadian. And he can even speak Canadian reasonably well. So.
Hey,
True story.
Yeah, but thank you very much for inviting me, Aaron. It's been a lot of fun. Loved hearing your questions and, telling a little bit about how the whole thing works. And, I hope, everybody's thinking about how can I get more airtight and make those incremental changes. Cause I think airtightness is one of those things you're not adding a ton of cost. It's just some attention to detail and some sealants and, and you can really make a big improvement in the house.
Well, maybe someday we'll have you back on and we'll talk like multi-point testing or something like that.
Yeah, I'd love to be there.
Cool.
awesome.
Well,
Thanks, Steve.
Thank you, everybody.
Long.